Hello everyone, welcome to Nafi's Learner Zone. So today we are going to start a new chapter in chemistry. So this chapter is about a very important element. The element which is known as a versatile element. So what is versatile means? Versatile means which has almost all the capabilities or which find use in almost every field. So suppose when we say about versatile, we can even say it as an all-rounder. So being a sportsman or a cricketer, we call a cricketer as an all-rounder if he can able to bat, ball, field, everything. Or in case if he has talent in most of the areas, we call it as an all-rounder. Suppose if you are a cricket fan, hope you know AB de Villiers. AB de Villiers, we call it as a versatile batsman because he has every different cricketing shots. So he's called as Mr. 360. It's because of his versatile nature of it batting. So same way, if you are a fan of a Bollywood movies, then hope you know Ayushmann Khurrana, who is a versatile actor. He has skills in many fields like acting, anchoring, music, as well as he's a singer. So lots, so many such. We call many human beings as an versatile. So like that, is it a element which is versatile in nature? An element? Yeah. In periodic classification of elements, you have studied there are around more than 118 elements in the periodic table. So out of those elements, is there any element which is versatile, which find use in many different fields? Yes, it is there. That versatile element we are going to discuss in this chapter, and that element is none other than carbon. Okay, carbon is the most versatile element in the periodic table, in the sense the most versatile element we know which is present on the earth. So what makes this carbon so special? Why it is known as a versatile element, and why carbon itself been studied in a separate chapter? The chapter which we are going to begin today is carbon and its compound. So carbon and its compound, a separate chapter has been kept only about carbon. Not only that, the study of carbon has a separate branch of chemistry that's known as organic chemistry. Organic chemistry mainly deals with the study of carbon and its compounds. So what makes the carbon so important and so versatile, that we are going to discuss in this video now. What's the atomic number of carbon? You know about atomic number, you studied in ninth standard, as well as in the previous chemistry chapter you have came across that. So atomic number is nothing but the number of protons present in the nucleus of that atom. So how many protons are present in that, or how many electrons? Number of protons will be equal to number of electrons in any neutral atom. So what are the number of electrons or protons in that? Yeah, that's 6. So there are 6 protons and 6 electrons are present in carbon. It means the atomic number of carbon is 6. So how do we write its electronic configuration? Just representing the electrons in the respective shells. We know there are many shells. For general, we study about 4 shells, K, L, M, N. So representing electrons in that shell. So 6 electrons. How do we represent? K shell can occupy maximum of 2. So K2. And the second shell is L shell. And the remaining 4 electron will go into the L shell. So the electronic configuration is 2, 4. Right. So there is one more thing which we studied in 9th standard after electronic configuration. That is number of valence electron. What's the number of valence electron here? What is valence electron? Valence means the ultimate or the last shell. In the last shell, there are 4 electrons. So there are 4 valence electrons. What is the valency? Valency we can calculate by knowing what are the number of electrons need to be gained or lost to attain octet state. Octet state is in stable state. every element wants to have a stable octet state, means should have 8 electrons in the outermost shell. For that, the elements tend to react. So that's what we are going to discuss in all the chemistry chapters. So in this chapter about carbon, so carbon has valence electron 4. So to attain octet state, how many it has to gain? 4. How many it has to lose? That also 4. In both the cases it is same. So suppose if we take sodium having atomic number 11, electronic configuration 2 comma 8 comma 1, 1 is the valence electron, so it can easily lose 1 and become stable by reaching 2 comma 8, that is atomic configuration of neon. Okay, so when it comes to chlorine, chlorine has 17, 2 comma 8 comma 7, so it needs one more electron to be stable, so it gains 1. But here what carbon should do, whether it should lose or gain, what has to be done? Confused, right? Yeah, that's why this chapter is separate, because it neither gains nor lose. It what? Let's see that later. So why doesn't it gain and why doesn't it lose? That is very important to know to understand the next phenomenon. Right, so why doesn't it gain 4 electrons? So it has 4 electrons in the valence shell. So if it gain 4, it gets stable, it gets octet state. Why doesn't it gain 4 electron? If it gain 4 electrons, so just see there are 6 protons in the nucleus, and if it gain 4, 6 plus 4, there are 10 electrons. So holding 10 electrons with 6 proton is quite difficult. Okay, because it will be held with the nuclear force, the force between the nucleus and the outermost electrons, that we had discussed in the periodic classification of elements. If you haven't watched that video, please go back in my playlist and watch the videos on periodic classification of elements chapter. Okay, and come back to watch this. So the force between the nucleus and the electrons, that holds it. There is nothing, there is no Faviquick or Fevicol being used to hold that. So what is being used is the nuclear charge. So with 6 protons and 10 electrons, it's very difficult. The nuclear charge gets imbalanced and it's difficult to hold. So it cannot gain 4 electrons. Why don't it lose? If it can't gain, why don't it lose? Then there will be a lot of space. Why don't it lose means if you have to remove 1 electron from an atom, you have to provide lot of energy. That energy is known as ionization energy. So to remove 1 electron, you need energy. To remove 2, you need still more, 3, 4. You need to remove 4 in this case. So to remove 4 electrons in this case, it's quite difficult. 4 electrons has to be removed. It's quite difficult. It means, in the sense, it has to be, we have to provide lots of energy to remove that electron, which is quite difficult, and it takes place only in some specialized reaction which you are not going to study in this high school or in the PU level. You are going to study it in the higher chemistry level if you study that. So need not to discuss about that. So now remember, it cannot lose or cannot gain. So what does it do? It shares its electron with other atom which also shares. So as you had studied in the previous classes, that by gaining or losing of electron, there will be one type of bonding which is formed in the elements, that is known as ionic bonding. But here what do we have by sharing is covalent bonding. Got it? So that's the first point you should know about the carbon undergoes covalent bonding. So compounds which undergo covalent bonding, they are known as covalent compound, as well as we call them as organic compounds. Okay, why do we call organic compounds? It's because most of this compound is being found in organic matter, in plants, animals. Okay, that is why we call it as organic compounds, and the branch which deals with these all carbon and its compound, we call it as organic chemistry. Okay, So further, you should know about what is covalent bonding and what's ionic bonding, the difference between covalent bonding and ionic bonding. That's important to know. Then further, we will go in detail about carbon. So how, and there are for more properties of carbon which we are going to discuss in the next video. Thank you so much for watching this. Please don't forget to like, share and subscribe.